Good afternoon, everyone. Today I'll be talking about solid principle in PHP. Okay, so you know me already. So solid principle. It's a set of principles. They are not set in stone, but they are uh, these these things that you want to go by when you are writing your code. Following solid principle as a developer, it helps makes you write a clean code, reusable code that is maintainable, testable, and then extendable. So solid principle as I said is not like compulsory, but it will help if everyone can relate to your code, and it is just easier when it comes to collaboration. You can imagine if somebody comes to your code base and then can say that you're not practicing the solid principle, and then the person gets a ticket and then they want to say find a bug, and then because your code is not relatable, they don't know where the model is or where the function that is causing the bug is or how to find the view itself. So it is best that we just live in our own little way as a developer, help each other to um, to use this kind of principle, and it all makes us better at the end of the day. So solid principle is a collection of principles actually. It contains these 5 principles: single responsibility principle, the open or closed principle, physical substitution principle, interface integration principle, and dependency inversion principle. So we're going to start with the single responsibility principle. Um, in Yi, we have our model, and how each model is basically talking to a particular table in the database. That is a single responsibility. So single responsibility principle is saying that a class should only change if a class should have only one reason to change, and it means it only has one responsibility. So if a class has more than one responsibility, it is already failing single responsibility principle. So in a case, say we have like a bookstore. In this bookstore, we have a manager and a front desk attendant, and then we don't want to gather data about this bookstore. We have the number of bookshelves, the books themselves, how they are related to having different genres and authors and all of that. So you want to put the genres in a different table. You want to put the authors in a different table, and the book themselves, their names, their ISBN, put them in a separate table. So each of these things, they have a single responsibility, even though the author is related to the books, the genres, they are related to the books. They all stand to have a single responsibility to know the detail that they contain. Basically, that is what single responsibility is all talking about. And with Yi, it makes us easy to adapt that kind of behavior into our code base. So okay, this is a funny picture. You have a fork and you have a spoon. So instead of saying that, say the manager says, okay, I want to be able to export the details of a book into a PDF, or I want to be able to download them in a PNG format, like transcribe it to a picture or something. You don't want to write those kind of functions inside a model or in a particular class. They already stand for something. And what they stand for is you're supposed to be getting data, not making it to do or take actions in particular. So you don't want to mix up some things. That's why we have something like utils in our like a folder called utils, where you can write those kind of functions. So single responsibility. So why should we use single responsibility? Follow this. You know that a class will have limited objectives. That way, the the details that you need, and they're not like too much. They're not cumbersome. They're just like 5 things that I need from a author's table. You know the name of the author. The author has a ID. That's all. It's limited. Basic database logic. If you can find it in one table, not that there are some other stuff on that table that are not related to a author's table in particular, and they are just there. Okay, so the pros of SRP is the separation of concern. Each table, they have their own detail, they hold their own responsibility, as it were. It is easy to collaborate when it comes to, say, a table. Let's say models. Say in models or widgets, it is easy to say, okay, I know where this thing is happening. I know how to adjust or get the query that I need to use. Not that we are finding some unnecessary functions in a model, and it won't be easy. And sometimes you might not even know, say, we already have this function. It is supposed to exist here, but it is here, and all of that. So it makes collaboration easier, and then it provides a maintainable architecture, obviously. Because when everything has its own responsibility, you basically just know where to go at every particular point in time. So when you violate the single responsibility principle, you are violating tell, don't ask principle. So tell, don't ask is how we have getters and setters in our whole key. So once you get data, you are not pushing it to make actions in particular. So at the end of the day, you want to tell your model that this is the query that I want to get, and I'm taking it out from you to go and use it in the controller. You don't want to be putting the actions that will be done in the controller, putting it in the model. Basically, that is don't tell, don't ask. Okay, the second principle, open or close principle. It says classes should be open for extension but closed for modification. We have our base model where we only extend classes. We don't actually have access to, say, you want to edit them. So in cases where we don't have, say, base model, but you want to create some set of functions that you know will be reusable, you know, say that you should not be able to modify them. You want to make sure that, say you want to modify them. So this function, you want to really say, okay, want to hash a password. There's a function already for that. But it happens that for this module that you're working on, not just want to hash the password. You want to say, I want to test if the token for that password has already been used. And if it has been used, I don't want the user to have access to that token again. So in this case, you don't edit the already existing function. You don't modify it. What you do to it, you write your own logic to effect the change that you need. You basically do that. That is, I've been open to extension, but you do not modify the already, because when you have to modify, say, in the use case that you are trying to work on, you say you go ahead to modify it. And then in other places that it has been used, it will cause problem. That means you have to go to other cases and see how it has been used and make sure that the logic you're adding to it is not affecting those other cases. So, okay, modification means changing the code of an existing class, and extension means adding a new functionality, like adding a new logic that, okay, if this token has been used, I want you to try an exception that, okay, if it has already been used and all of that, something like that. Okay, so this is saying, this is a mixer for making cakes. So the head of the mixer, it stays just like the function, the password hash function. And then you just change the attachment based on logic, really, that, okay, in this case, that this is what I want this thing to do. And in another case, this is what I want it to do. But you do not change the original function itself. Okay, yeah. So when you are following the OCP principle, you want to make sure you are using classes, you are making use of interfaces, traits, and all of that. That way, your code is reusable. That way, you avoid creating potential bugs, like I mentioned earlier. That well, when you have to go back to that base function and you update based on what's on your own use case, it's going to might cause problems. So you want to avoid that. You still want to use the function, but at the end of the day, you want to be able to add your own logic to it. There's ease of adding new cases to application, and then the separation of logic. Okay, list curve substitution principle. This principle is saying that each class that inherits from another can be used as its parent without knowing the difference between them. Okay, I'm going to use a less technical, but not less technical. Say we have a button that is used across all pages. You've designed this button to have the same, say you have a background color, you have a color, the border radius and stuff. You've designed it, and then the only thing that is changing in this button is the name inside it. You are able to reuse it in any way you want it, but the button in itself does not change at all. So that is what this stuff is saying. This stuff is saying that you create your classes, and when you use them, the parent itself, when you reuse them, it doesn't change the parent, and then the classes that inherit them, they can go ahead to work without changing the parents, basically. You won't know the difference between them. The buttons, they will look alike, and the only thing that will be different is just the name inside it, like submit or proceed or next or previous, something like that. So, okay. So we have like the big buttons here, and then so this big button is LD, means is LD, and then that means the small button means is LD. So in a particular way, the original guide, it has a default value that says proceed. But when you go to reuse it, you put next inside it. It's something like that. So nothing about the button changes. It's just the name inside it that changes. That is what list curve substitution principle is basically talking about. Okay, so fun fact, list curve principle was introduced by Barbara Liskov. She is one of the first women to earn a PhD in computer science in United States. Yeah. Okay, following LSP principle, so you want to make use of interfaces, classes, and functions to be able to use this principle. And then, of course, there's code reusability, there's separation of concern, and then that means that, okay, say you want to use that button that same way as the parent in itself, there's no problem to it. And then there's ease of maintenance, since practically maybe just one thing you are changing, and you don't have to make the change in the parent class in itself. Okay, the fourth principle, interface segregation principle. Okay, so it says that an object of the parent class should be replaceable by its object of its child class without causing issues in its application. So ISP is almost like what's it called? The list curve substitution principle. ISP is saying that you want to be able to say you have a group of you have like a function. I want to use that function in other places. Just pass in your own variables. Don't update it or anything. Just use it as its parent. You won't. When you extend it, it won't affect the parent, and then basically the child that is using those functions or class will be able to use it fine, and it won't affect anything in the application itself. That's what interface segregation principle. But in the interface segregation principle, what I'm making use of mostly is interfaces. Interfaces or abstract classes. Okay, so the original guide stands by itself, the base class, and then what you want to use it for, it basically changes. So you make use of interfaces, but you make sure that you are extending the interface itself so that you can use it for what you want to use it for. So following the interface segregation principle, it makes use of interfaces, the purpose, code readability, method of flexibility. It enables single responsibility principle. So when you have the function in itself, that you know that it doesn't change. Like say you want to uh, hash a password, you know that the function itself is already hashing a password. Then you want to reuse it, and then you want to add more logic to it. The function name itself is going to change because of what it is going to do. So at the end of the day, it is still handling a single responsibility. It is still hashing the password, and it's still comparing the tokens and stuff. So there's separation of concern as usual. The fifth one, dependency inversion principle. It says classes should be dependent on interfaces or abstract classes instead of concrete classes and functions. So we have a PHP-based model that there are a lot of functions in there that some of them I don't even know. So this principle is saying that higher order classes, small order classes should extend to those higher order classes. You want to be able to use those classes instead of say some functions. There are some utils that you can use, and then basically you don't want to depend on them. Like when you extend your classes, you don't want to extend say utils in its sense. You want to extend the model that holds the utils and stuff. Yeah. Okay. So this is saying that even though there are different implementations of that stuff, the main guy should still work irrespective of what you plug into it. When you extend your base model and everything else, like the other functions that are inside it, you want to make sure that this plug still works irrespective of the kind of wire that you put into it, basically. So the dependency inversion principle is saying it's making use of interfaces, and then you have dependencies in it as well. So it facilitates modification and then replacement of implementations. So classes are open to extension. You only extend them, you do not modify them, you don't update them whatsoever. Yeah, and then it implements more than just the open of this principle. It implements list of substitution principle as well. So if your code is not solid, that means in one way or the other, your code is probably stupid. So stupid stands for singleton, tight coupling, untestable, premature optimization, indescriptive naming, and duplication. Duplication in the sense of do not repeat yourself. When you have a function more than one place and they are doing the exact same thing, create a whole function and basically extend. Thank you very much. That's all.
The last one is dependency inversion.
Yes.
What do you mean by dependency? What does dependency mean?
Like extending a class in itself. So that class, it's a higher order module compared to what it is extending itself. That the class that is using that higher order module.
So you're saying like let's say I have a class and I extend the class. That extending should be to not complete.
Yes.
This is very very something. I think I'm get the function.
Yes, because I was relating it to ye. No, I was relating it to
This
ye.
function.
You said
This function.
yes.
So like I need to extend.
No, you can't.
But let's say like function.
Yes, I was trying to like use it in a way that people could easily relate with it. So basically, you can use study principle in whole classes, interfaces, traits, and so yeah.
So I noticed that it was all you mentioned, but how can they people in language like JavaScript and like, I write you, how can I apply these concepts in general sense to you?
So, in general sense, to view, I don't write to view, but in a way, view the framework, and I'm sure there's a way that you can at least write it such that it still follows the principle, maybe not exactly the same way, but in a way that you know that it is clean, maintainable, and stuff. And then at the end of the day, you want to make sure that all your code is easy for people to collaborate on at the end of the day.
So I read an article, I think 2 years ago, last year, actually you remember. And the article mentioned that that the guys that use this, that some of this solid and this man, this old man, Bob. Since Bob was quite dominated and this is quite dominated. Started dominated, right? And this cannot like this should apply. This should not apply to every
Yeah,
instance of even hope. So like even hope you should apply. It's not the hard and fast at the
yes,
moment.
it is not.
And but people were like saying that it's going to industry. Like some of the thought I think at all industry. I'm not saying like what I read that.
Yes, obviously. But it makes sense, like SRP, it makes sense for you to practice SRP.
Yeah, well,
or open or close principle and the rest like that. Maybe not all places that you can use them, but in some cases you want to make sure that your code makes sense and people can easily read it.
yeah, well, the intention behind this is pure, right? But then, for example, now I don't kind of agree entirely with the last one of the medicine of the version. I mean, I may want to, okay, I can do that to I may want to extend the complete class. Use extending the complete class. Sorry, and secondly, secondly, you mentioned there was one point that he was one of the first yeah, open close musical.
Second one.
Yeah. So in my written code that I had to change the state of the class when I'm using the class. I mean this one was against it, doesn't it?
So let me know. Open was closed, is not open and closed like this. Open was closed. Open for extension, closed for modification. A very good example would be, can you take back to the example? Yes. Now, if it was supposed to be closed, that means we buy a different mixer for whiskey and a different mixer for all of those. This is all you have to change. So that is this is open. This place is open for extension. This makes it closed for modification. Now, if you have to do if you are having to change that a lot of time, that means you've broken the first rule, which is single responsibility. Yeah. If all your eye does is capture image, your eye does recognition. That's the work of your brain. Now, if your eye does capturing, recognition, labeling, and all that, if your eye is faulty, God will not hear the faulty. That means technically you've lost solution. So simple responsibility is the way organisms evolve. A cell basically has one purpose. Then too many cells gather together to form a tissue, to form an organ, and then you go all these organisms. So if you violate that first principle of open and of single responsibility, you most likely violate other principles. So the principle of inversion, dependency inversion, it's one of the best places where if you use what's the name? Interfaces. That's one of the best places to use interfaces. all you pass to that function is an interface. And by the definition of an interface, all functions, all classes extending that interface implementing it must implement it. So basically, if you are writing an interface instead of writing a complete code, it means
And that's the case. Using an interface is going to extend a concrete system, which means you can even change stuff.
implementation. Take for instance,
Change implementation to
the way
suit your new
the way
use.
insect talks is not the way human talks.
Yeah.
So now imagine if when God was creating it, God was writing a class for animals.
Yes, I get that, right? But I'm saying that I don't know. I can't get that right. I'm saying that the time is about to extend class that is not abstract of
If you have to do that, that means you're designed from scratch.
Yeah, it's different.
It all starts from design. It starts from design. Take for instance, there is a function for retrieving record from the beginning, right? And if, for instance, I know I'm always saying get ID, right? Just get ID. And then for some reasons, you need that needs to be able to get ID and name. Ideally, it should be a different function. Or I have another function to get name. And then I call those two in a different function. Which means if I want to use ID in a different place and name in a different place, I can have another function. Single responsibility. If you violate single responsibility, you are most likely going to violate others. So if you get your single responsibility right, you most likely get others right. So maybe in the design of the system, it's not just in coding. I think maybe that was, it should start from your design. If you separate things properly, you not have cost to do. It's one of the issues. It's one of the issues we have in assessments.
Yes.
Enrollment, registration, and assessment.
Okay, so then back to this one, there might be different by. So okay, so what I was saying was that we have to change the state of the class. Like, let's say the class has some states, some states. Let's say it defines states and not.
Say, for example, you have a man and the man
Yeah, right. I mean, you can't have. I mean, what I was saying was that I can't. I'm not have to change the state of a information. I'm not have to change the state of a class, right? And why then do I have to set up?
Sorry.
Let me help you out.
So
So let's go back to the definition. This is the first we're talking about. Let's go all the way back to the beginning. This is why you have set and getters in the first place.
yeah,
They do only one thing, they set or get value. Now, if you are setting value in one place, status, set value, set status as a way.
yeah.
Now, if I have a function to set awake or asleep, if setting asleep for you means closing two eyes, open for extension is in my own sleep. I have a function close eyes. I have another function close mouth. I have another function snore. For people that don't snore, I have and they open their eyes. I will not have closed eyes. I will not have open mouth. Or if they open their mouth, open mouth. I will not cause snore. Now, it is open for extension. I've extended the function of the sleep, but I've not touched
The main
the
sleep.
main sleep
But they also sleep.
because it's still all sleep. So when you have to go back to the base, basically means you should build up. If you don't have access, just imagine you don't have access to base class when you are building the game.
So sorry. When they get access, I think what's
Code-based access.
like access to class. I think what you are missing is you have access to those change those things directly.
Modify.
I think that because I mean, I think that can't change
No,
it
not even,
by
not those modifiers. Not those modifiers. Changing the code base itself.
And
That's
like,
not tightly portfolio.
like my question was
More around
more
properties.
property and
No, it's more around functions. That's why they say your class, your functions, not your variable. Your variable can have that level.
So on the phone, I have this convert to provider, which is sorting by created as. At the end of the day, there was not like on some other tables we don't have created as. So we have to start using another function instead of what they refer to as the base function. So going forward, you need to be tightly copy your base classes.
yeah, like here. Go on. So I think my picture about so
Okay. So at the end of this, like there are some articles that you can read for paper understanding of solid base. Thank you.